hello, and welcome to Math Blossoms, where growing in mathematics is natural. I am the teacher, Miss G, and for today's math topic, we are learning how to solve equations with variables on both sides of the equal symbol. There is another video I'm going to make on top of this one that I want you guys to watch separately. So after we do this video, there's going to be a second video on special cases that may come up when you are solving equations with variables on both sides. Today's video is simply how do we solve them when there's one solution. So we're going to practice doing that. I'm going to go ahead and review it. The vocabulary with you first. Hopefully you've watched the one-step equation video, the two-step equation video, and also the equation video with distributive property. And if you've done all of those and you understand those, then this one's the next step up. So let's go ahead and get started reviewing the vocabulary. Expressions, equations. The difference between an expression and equation is the equal symbol. And it does contain at least two numbers, variables, or both, and at least one operation. Terms in a single expression in an algebraic expression, or equation that can be a number, a variable, or multiple variables multiplied together. Remember that terms are separated by operators like plus, minus, divide, multiply. Also by symbols like equals or less than or greater than symbols. Coefficients, the number or symbol that multiplies another number or symbol, such as a mathematical variable. So if you look at the coefficient at the bottom there, it is not the x, it is just the 7, okay? The term is both. The term is 7x. The coefficient is just the 7, and then the x is the variable. And then constant, the number or symbol that has a fixed value and does not change, that would be the number 2 or the 9. And then the variable, of course, is the letter that we use to represent an unknown quantity. All right, that being said, let's go ahead and get started with some practice. And on here, we've got... Oh, I forgot to review this. Use, for one thing, what is our question? How do we solve these equations? We use inverse operations to solve equations in a specific order. Inverse means opposite, and we've been doing this all along, but today we're actually going to be using all of the steps, not on every equation, but we're going to be using them on some of them. So again, when we use the don't call me after midnight method, we're starting at the D and we're moving our way down. If distributive property is not present, we go to combine like terms. If that's not present, we move on to the move variable. And the move the variable step is the important one for today's lesson, because that's how we get a variable to become only on one side of the equation instead of both. And that is necessary in order to solve that equation. So the order or steps to solving equations can be remembered with the phrase, don't call me after midnight. And for equations with variables on both sides, we will need 2 or more of the DCMAM steps, including move the variable. Again, moving the variable is the important step for today, but of course we do have to check for all the other steps as well. Here's some practice. So let's go ahead and start with the first one. The first thing I'm going to check for is distributive property. There is no parentheses in that equation. So since there's no parentheses, I don't have to distribute anything. So check on that one. The next step is combine like terms. Now here's what I tell people to do when you're combining like terms. Okay. Pretend, let me see if there's, I'm just going to highlight. I'm trying to think of a way I could do. Okay. I'm just going to just cross that out. Just cross out all of this for now. Just cross it out. Pretend none of that's there. Okay. And just look at these two and say, can I combine those? Are they alike? Okay. And if they're not, then you can't. Right. And then look at the other side. Right? So after I crossed it out, I'm going to erase it. I'm going to cross out the other side. Now, the reason I'm going through the trouble of crossing out each side so that we can look at just one side at a time. And as you can see, I could not combine the 4x with the 21 either. I'm doing that to prove a point. A lot of students like to hop over that equal symbol when they're combining like terms. And that's not something you should do. If you're moving over that equal symbol to combine that 8x with that 4x, it's going to change your equation in the wrong way. So always check on both sides of the equal symbol separately to see if you can, combine those like terms. And there's nothing to combine on this one. Oops, I lost my pen. There's nothing to combine, so we're done with that step. And now we're on the move variable step. Again, it says at the bottom here, this means to cancel out the variable on one of the sides of the equation by doing the inverse or opposite operation. Well, what's going to make a 0 basically is what you should be asking yourself. How can I get rid of this 4x? I can get rid of the 8x or the 4x. I'm just going to do the one on the right side, but it really doesn't matter which one you get rid of first. The only reason why I chose the right side is because I know that will make my variable on the left when I'm finished. And I like having things say x equals something instead of something equals x. And both are true. You could do it either way. So basically, we're going to use, for the move the variable step, we're going to use either addition or subtraction. Now, this 4x, if I add a 4x to it, I'm going to get 8x, and that's not what I want. I don't want an 8x. I want it to 0 out. So what I'm going to do is subtract a 4x. Again, we're going to either add or subtract to get rid of that variable, okay? And since I got rid of that one, I still have to do that same operation on the other side. Remember, to keep our equation balanced, we have to do it on both sides. So I'm going to subtract 4x over here as well. And when I do that, I get 4x. And remember, we can only add x's with x's or subtract x's from x's. Now I'm going to rewrite my equation, leaving out the stuff that I canceled out. So on the left side now, I have 4x minus 7 and equals, and then over here on the right, I just have a 21 now. And then we're done with that step. So now we can go to the add subtract, and what's being added or subtracted to my variable is the 7 here. So I'm going to add a 7 to 0 that out. This is called the additive inverse property. It's used every time pretty much you solve an equation, well, almost every time you solve an equation like this. When we add these together, we get a 28. And again, I'm rewriting my equation, leaving out the thing that I canceled out. That just helps you to see what to do next. And now we have 4x equals 28. And the last step is whatever's being multiplied or divided with your variable, do the inverse. So since 4 is being multiplied times x, I'm going to do the inverse and divide it. 4 divided by 4 is a 1x, which is what I want. And 28 divided by 4 is a 7. So our answer for this one is 7. Pretty simple. I mean, once we did the distributive property video and you saw how those were done, this is kind of similar. You're just going to go follow through all of the steps. This is why the don't call me after midnight method works so well, is because it reminds you of what to check for every time so that you don't skip anything. And sometimes not every step is in the equation, but you always check for it to make sure before you move on to the next step. All right, so now we are on this next one. And again, there's no parentheses. Remember, for distributive property, we need a parentheses. There is no parentheses. So we're not going to be distributing anything. Combining like terms, again, look on the left side. I cannot combine an x with a 9. And I cannot combine this negative 2x with this 45. So this is check. I can't do anything there. So again, I'm with the move variable step, and I have a variable on the right and on the left, and I'm going to cancel out one of them. This time it's a negative 2x. So if I subtract a negative 2x from that, that's the same as adding a 2x. Remember, subtract negative is the same as adding. And you can kind of think of it like this, it's like protons and electrons. If you're studying science and you're talking about, the parts of an atom, protons and electrons, the electrons are negative and the protons are positive, and together they neutralize each other. They just, boom, there's no charge, right? And that's kind of what's happening here. You've got a negative and a positive, boom, now there's nothing, right? And so you can kind of think of it that way, that additive inverse property. But since I added 2x to this side of the equation, I have to add 2x over here as well. And that's going to leave me with a negative 9x. And again, you can double check my adding and subtracting in your Desmos if it helps. I'm going to rewrite my equation. This time I have the negative 9x plus 9 on the left side of my equals. And then the equals. And then on the right side, the only thing I have is a 45. So we have done the move variable step. Check. And now we're on the add subtract. What's being added to my variable is the 9 here. So I need to subtract it to get rid of it again. Plus minus is going to zero out. Boom. And then I have to do it on the other side. So if I subtract a 9 from this 45, I'm going to get a 36. And I'm just going to rewrite my equation. I still have this negative 9x over here. And on the right side, I have a 36. And the last step, we did this step. So now the last step is multiply, divide. And since the negative 9 is being multiplied times my variable, I'm going to divide on both sides of the equals. Negative 9 divided by negative 9 gives me 1x, which is what I want. And 36 divided by negative 9 is negative 4. So there's our answer for the second equation. Now we're going to change colors and go to the next one. And the next one, once again, does not have distributive property. Again, we need a parentheses for that to happen. And there's no combining like terms on the left side. There's no combining like terms on the right side. So we're on this step, moving the variable. We have a 6x and a 13x. Again, I'm going to cancel out the one on the right. You don't have to. You can do the one on the left. You will still get the same answer. So it doesn't matter which one you do. I've gotten into the habit of always doing the one on the right. But sometimes if you're trying to avoid a negative, for instance, you might want to do the one on the left. So 6x, and that's a positive 6x. So remember what I said about positive and negative, boom, right? It's canceled out. And you have to do that minus 6x over here on the left side of the equation as well. That's going to give you 7x over here. And again, I'm just going to rewrite everything. 7x plus 9 on the left side of my equation. And on the right, the only thing I have left is a negative 12. Remember, that symbol in front of it is like its sign. So do not leave that subtraction there. Remember, a minus is the same as a plus negative, right? So this is a negative 12 here. All right, the next step is we did the move variable. So now we're on the add subtract. What's being added to my variable is this 9. So I'm going to subtract it here. And that's going to cancel out. And then I'm also going to subtract the 9 over here. And that's going to give me a 21 negative. Negative 12 minus 9. And then rewrite the equation, leaving out the stuff you canceled out. The stuff that you zeroed out there is not going to be present, but you do have the rest. 7x equals negative 21. And the last step is whatever's being multiplied or divided with your variable, do the inverse. 7's being multiplied, so we're going to do the inverse, which is divide. And 7 divided by 7 is 1. And negative 21 divided by 7 is negative 3. All right, now the last equation here, again, there is no, that's going to bug me. Check. I didn't do the blue check on that one either. Check. Okay, now we're going to do the last equation, and there's no distributive property. If you look over here on the left, there's nothing to combine. However, on the right, there are two numbers here that I can combine together. They're constants. Remember I said that you can only combine x's with x's, but you can also combine your constants together. So when you're combining like terms, it's very important that you keep the symbol that's in front of it with it, whether it be a minus or a plus or whatever. This is negative 2 plus 15. You could literally write it like that. Like I always draw shapes around it to just emphasize what I'm doing here. And what is negative 2 plus 15? Well, that's 13, right? So I'm going to, ooh, my 13 looks strange. That's a 13. Okay, so I'm going to rewrite this equation. Now I have 14x plus 1. And on this side, now I have an 8x and a positive 13 because I combined these two together. Okay. Now you really do need to do these first two steps before you start moving variables. I have a lot of students who forget to combine like terms sometimes, and they start trying to move the variable over, and sometimes they run into problems. So it's really a good thing to just get into the habit of doing that first, then start moving the variables over, because there could be other variables over there you need to combine together, right? So now we are on the move variable step, and that is, I have an 8x over here and a 14x. So I'm choosing to get rid of my 8x by subtracting 8x. If that was a negative 8x, I would have added 8x to both sides. All right. That's going to give us a 6x over here. And of course, the zeroed out one is canceled out now. So let's rewrite it. We have 6x plus 1 on the left side of the equation now. And on the right side, we still just have this 13 over here. Next step, because we did the move variable part, is add, subtract. What's being added to our variable? Let's subtract it. And don't forget, you can, 13 minus 1 is 12. You can draw a line. Some kids like to do this. I don't do this. I've never done this, but I have noticed a lot of teachers and students sometimes like to draw a line through their like basically they will draw a line through the equals so that they can keep their equations like separated, so that you know to do it on both sides of that equal symbol. So if that helps you, it's okay to do that, to draw a line through the equal symbol, just to make sure you're doing everything on both sides. When you're changing and like when you're using those properties that we're going to talk about in class, which is the add, subtract, addition property, subtraction property, division property, and multiply property. And of course the distributive property. So this final step here, multiply and divide, I'm going to go ahead and check it because we're about to do it. We are dividing by 6 this time because 6 is being multiplied times the x. And that's going to give us x equals 2 as our final answer. All right, so let's try one more, oops, or two more. How many more do I have? I'm gonna, switching from pen to, doesn't always work. I don't know why it takes forever. There we go, whoops. Okay, so I think when I'm streaming, when I'm recording my video, it doesn't register my clicks or something when I'm doing that. So we have another one here. Is this just one? Yeah, it's just one, but I wanted y'all to see one that has distributive property in it as well. So let's go ahead and get our pen again, and I'll just use, what have I not? I'll use light blue this time because I haven't used that before. And again, distributive property, we must see a parentheses. We have a parentheses here. So that means I have to start by distributing that 4 that's being multiplied times everything in that parentheses, right? So 4 times 2x is 8x. And then 4 times this negative 5 would be a negative 20. Or you can put plus negative. It's just easier for me to just put minus. And I'm just rewriting the rest of this as is. And then we are going to combine some like terms here because I see on the right side of this equation, left side, there's nothing to combine. We can't combine the 8x with the 20. But over here, I do have a negative 1 and a negative 7. And again, if you just write those down, negative 1 minus 7, that would be an 8. Okay. I'm sorry, negative 8. How did I leave that negative off? Okay, so negative 7 minus 7 is negative 8. So now we can rewrite our equation again. 8x minus 20 equals negative, well, I'll put the 14x first and then the minus 8. All right, so now we're down to the move variable part. Oh, I forgot my x on the 14 there. Okay, and here's a situation where when I cancel this out, like let me just show you this example. When I cancel this out by subtracting 14x from the 14x, when I cancel that out over here, when I subtract the 14x from the 8x, I'm going to get a negative. And sometimes students don't like to work with negatives, so they'll cancel the 8 out just so they don't have a negative x. Either way, they will work. So I'm going to rewrite my equation now. I have negative 6x minus 20 equals, and then there's a negative 8 over here. This was minus 8, remember? Negative 8. Okay, we're done with this one, and now we're on the add subtract part. What's being subtracted to my variable x here? That would be the 20. So I need to cancel that out. We're going to add a 20 to that minus 20, and that's going to cancel out. And when I add 20 to this negative 8, oh my goodness gracious, hang on. My 20 does not look like a 20. I'm going to fix that. Okay, 20. Here we go. And that's going to be 16. Nope, 12. I don't know where I got 16 from. That's what I get. Okay. There we go. 12. Negative 8 plus 20. Okay, so when I rewrite this equation, now I have negative 6x equals 12. And the last step, because we just did that one, is whatever's being multiplied or divided with your variable, do the opposite. And so we are doing the inverse of, multiply. I am just making mistake after mistake today. So we're going to divide by negative 6 on both sides. And that's going to cancel out and give us just an x, because negative 6 divided by negative 6 is a 1. And remember, we don't write the 1, but it is there in front of that x. And 12 divided by negative 6 is negative 2. All right. So now you've seen quite a few examples of how to solve equations with variables on both sides. We're still using the DCMAM steps, and some things to look out for. Focus on the operation that's happening to the variable and do the opposite or inverse. Now this is when you do the distribute first, do the combine like terms first, and then do the move variable, but always look at that operation when you start canceling things out. Be aware of invisible ones in front of variables or parentheses. Subtracting a negative number is the same as adding a positive number. And then when combining like terms, keep the operator symbol in front of the term with that term as a sign, combining each side of the equals separately. So I pointed that out in this video because a lot of kids want to hop over that equal sign when they're combining like terms, and we can't do that. We have to do them on the left, do them on the right, and then start moving a variable if there's variables on both sides. Here's an example of a invisible 1 here in front of this equation here that you have to distribute. That's a negative 1 actually. There's another negative 1 here. There's also a lot of terms you can combine on this one. And so, don't be afraid to try different equations. We did learn about an additional step that sometimes can come into these equations that isn't included in the DCMAM steps, and that's taking a square root or taking a cube root. There's a video on that, on how to solve equations with square roots and cube roots. But if those square roots and cube roots are in a multi-step equation like this, you still need to do the DCMAM, and then the final step would be to take the square root or the cube root if it's present in the problem. Great job, y'all. So remember to solve equations using distributive property, look for the parentheses. Don't forget about that. Multiply the number outside of the parentheses each time to each term inside the parentheses. When combining like terms, keep the operator symbol in front of the term with that term. So when you're drawing your shapes around the different terms to combine them, just keep that operator that's in front of it with it. So if there's a minus in front of it, think of that as a negative. Remember to cancel out the constant by adding or subtracting. Remember to cancel out the coefficient by multiplying or dividing. And then remember to simplify any fraction answers or round any decimal answers if necessary. And also remember, if you have time, to substitute your answer back into the original equation to check and see if you are correct. So that concludes our video on equations with variables on both sides. So the next video that you should watch is equations with variables on both sides with special cases. Very interesting video. You'll definitely need to watch that one. So we'll see you then. Now it's time for me to say it was lovely teaching you math today. Bye-bye.